Morning to all. This is Uma Shankar working as a lecturer in UNC at Government Polytechnic College, Kochi. So today I am going to deal with the subject Advanced Engineering Mathematics for Electrical Engineering students in 4th semester. So today my topic is Laplace transform. In this, I am going to discuss about the Laplace transform of elementary function. So in the last class we have seen the some of the that is nothing but the definition of the Laplace transform and also the sufficient conditions for the existence of Laplace transform and advantages and also the applications. And next we have seen the first general property of the Laplace transform is nothing but the linear property, and we have seen the one or two elementary functions how we are going to apply the Laplace transform. That is, we have found the Laplace transform of one and also the Laplace transform of t power n. So this is the generalized formula for Laplace transform of t power n. So if you see here, Laplace transform 1 can be written as 1 by s. Laplace transform t is equal to 1 by s square, so on up to. So generally, Laplace transform t power n can be represented as n factorial by s power n plus 1. So this is your theorem statement, and you have to prove that theorem. Already we did this proof in the last class, and also we have we have evaluated and we have found the Laplace transform e power 80, that is nothing but 1 by s minus a. And similarly, it has to applicable for Laplace transform e power minus 80 also, that is given as 1 by s plus a. So all this we have completed in the last class. Now in this class we are going to explain about the Laplace transform of sin 80 trigonometric function. Laplace transform of sin 80 can be given as a by s square plus a square. So we have to prove this one. Okay, right. So we know that by definition, Laplace transform f of t is equal to integration 0 to infinity f of t e power minus st into d. So now we have to find out the Laplace transform of f of t function. What is this f of t function? Is nothing but your sin 80. So in place of f of t, you have to substitute as sin 80. Here also sin 80. So we know this sin 80 can be represented in a exponential form. So we know the formula for sin 80 is nothing but, so according to the trigonometric formula, it is nothing but in trigonometric, the sin theta can be represented in terms of exponential is given as e power I theta minus e power minus I theta by 2y. Okay, so here in place of theta, we'll have the 80. So wherever you have the theta, just substitute 80. Okay, e power I 80 minus e power minus I 80 by 2y. Okay, right. Right. So this is in place of sin 80, we have substituted in terms of the exponential into e power minus st into 80. Okay. Right. So now if you see in this slide, okay. So we have separated that exponential. That is nothing but integration e power I 80 into e power minus st into dt as one integral function, 0 to infinity. Okay. Next, plus again 0 to infinity e power minus I80 into e power minus st into dt. This is the another integral function. So take in the denominator you will have the 2y. So take this 2y outside. This is 2y outside. Term is outside. Okay. So now it is of the form a power m into a power n. There also it is of the form a power m into a power n. So then if you convert this one as a power m into a power n, then it can be converted as a power n plus n. That is, bases are same, powers can be added. So if you simplify this, you can get this term. If you simplify this, then you can get this term. Okay, right. So after simplification, then what you have to do? So you have to do the integration of e power minus 80. This is of the form e power minus 80. This is also of the form e power minus 80. Okay, right. So apply the integration of e power minus 80 formula. In place of a, you will have the s minus a. You will apply the integration of exponential function. Then you will get e power minus s minus a into t by minus of s minus a. Okay, because what is the t coefficient? Minus of s minus a. Okay, that is it will get in the denominator. So here also you will get as a same. Here you will get s minus a. Here you will get the s plus a. That is the only difference. Okay. So now we have to substitute the upper limit in t and also the lower limit in t. And similarly for this term also we have to substitute the upper limit in t and lower limit in t. Okay. So after substituting and simplifying, what you will get for this function? So for this function, what you will get is nothing but, so for the first value, after substituting the infinity in t, you will get it as a 0 for the first term, minus for the second term you will get it as a 1. Okay, so you will get it as a 1 when you substitute this lower limit in t. Okay, so e power 0 you will get it as a 0. E power 0 value is nothing but 1. So outside of this function, first function, what you have? Minus of s minus a, that is minus of s minus ia. So minus of s minus ia. Okay, so minus into minus you get it as a plus. Finally what you get? 1 by s minus a, that is the first term value. Okay, after evaluating by applying the upper limit in t and also the lower limit in t, you will get 1 by s minus a. And similarly for the second term, by putting the upper limit and the lower limit, okay, you will get this term as 1 by s plus. Okay, so this is the simplification of this first term. This is the simplification of this second term after applying the limits. So take the LCM of this. Take the LCM of this. What will get LCM? 1 by something, some division, that is nothing but s minus a into s plus a. Okay, and this term will be multiplied with respect to this first term. This multi will be first multiplied with respect to this second term. So you get it as a s plus a, s plus ia, okay, by, that is s plus ia minus s minus ia by s plus ia into s minus ia. After simplification, you will get this one. So this pluses and this minuses, minus into minus plus, you get minus here. So minus s term and this plus s term both will get cancelled. So here plus ia. So here also minus into minus, you get it as a plus. Again, you get one more plus ia. So plus ia plus ia. That it is nothing but 2ia. Okay. So if you simplify this numerator, you will get the 2ia. In the denominator, you will get it as a it is of the form a plus b into a minus b. So it has a square minus b square. A square minus b square. Okay. So a square is here, yes. A value is a, yes. B value is ia. A square minus b square. So what you will get? S square minus I square into a square. I square into a square. What is I square value? Minus 1. Minus into minus, you will get it as a plus. So finally, in the denominator, what you will get is nothing but s square plus a square. Okay, you get s square plus a square. So the denominator simplification, you will get s square plus a square. The numerator simplification, you will get it as a. How means? So this 2i in the denominator and 2i in the numerator both will cancel. Finally, we will get it as a by s square plus a square. Okay, so this is the way you have to simplify the Laplace transform of sin 80. So finally, wherever you will find this Laplace transform sin 80 term, okay, for this type of function, then you can directly write it as a by s square plus a square. This is the generalized formula. So this can be exist for only s greater than 0. And similarly, for the cos 80 term. So Laplace transform cos 80 is given as s by s square plus a square. It is also defined for s greater than 0. Okay, right. So now we can go to find out the Laplace transform of sin 80 and cos 80. Okay, by using the alternative. So Laplace sin 80 and Laplace transform of cos 80. Okay, we can find out by using the alternative method in a single function, by using a single function or single term. Okay. So we can get Laplace of sin 80 and cos 80 by another method. That is nothing. We know the Laplace transform of e power 80. What is the Laplace transform of e power 80? 1 by s minus. Already we did, and we have verified this theorem. This is also one type of theorem, and it can be some function where we are going to apply the Laplace transform for this function to get the Laplace transform of this exponential function in terms of s. Similarly, Laplace transform e power 80 can be written as, okay, Laplace e power I80 can be written as 1 by s minus a. Here you will have a t coefficient is a, that's why you will get s minus a. Here the t coefficient is ia. That's why you get s minus ia. Okay, right. So now what we have to do? So for this term, multiply and divide both numerator and denominator by s plus a. Okay. So in the denominator you will have only s minus a. So what we have to do is nothing but multiply and divided by s plus a, s plus ia, and s plus ia both numerator and denominator. So if you cancel out this, again you will get the same term. Okay. For the numerator you will have the s plus ia only. For the denominator, again it can be converted as a plus b into a minus beta. So the simplification of this finally you get it as a square minus I square a square. So a plus b into a minus b is nothing but a square minus b square. A square value is s square minus b square value is I square a square. So what is I square value? I square value is nothing but minus 1. Minus into minus plus. So finally we get it as a square plus a square. A square plus a square. Okay, right. So again we know uh, the basic formula of the exponential is nothing but e power I theta is equal to cos theta plus I sin theta. Okay, cos theta plus I sin theta. So then here also Laplace transform e power iat can be represented as, in place of theta we have a at. Okay, we can convert this e power iat in terms of cos and sin. So that's why Laplace transform cos at plus I sin at. In place of theta we have to substitute at. Okay, Laplace transform cos at plus I sin at. Already we have simplified this Laplace transform iat can be represented as s plus ia by s square plus a square. Okay, so we have written that one at the LHS. Then what we have to do? So we have to just simplify this exponential term in terms of the cos and sin. Okay, real and imaginary values. You can represent in terms of real and imaginary values. Okay, right. So now after simplifying this one, so this exponential can be represented in terms of cos and sin is equal to. So already we have evaluated this exponential Laplace transform of this exponential value as s plus ia by s square plus a square. So by the linearity property. So now for this function you have to apply the linearity property. What is the linearity property? That is Laplace transform of the sum of the two functions. Okay, if you apply the Laplace transform, sum of the two or more functions, that can be written as the sum of the Laplace transform of the individual functions. The sum of the Laplace transform of the individual functions are the separate function. So now we have to apply the Laplace transform cos at plus I into I is nothing but imaginary. I into Laplace transform sin at is equal to. So you have to divide this this term, this entire term as real and imaginary. We can separate the real value and imaginary value. That is, so we can divide this one into the two terms. One is s by s square plus a square, okay, plus ia by s square plus a square, s square plus a square. So we are dividing s by s square plus a square and also the ia by s square plus a square. Okay, we are dividing into the two terms. So here it is real value and the imaginary value. So now we have to compare the real value, okay, and also the imaginary value on both sides. So Laplace transform cos at is equated to s by s square plus a square, and the imaginary value Laplace transform sin at is compared with the imaginary value, that is equal to a by s square plus a square. Okay, so you have to compare the real and imaginary parts on both sides. What is the Laplace transform cos at is nothing but s by s square plus a square. That is transform sin at imaginary value, that is nothing but a by s square plus a square. This is the another alternative method in order to find out the both sin and cos function, both the trigonometric function. Okay, instead of simplifying using the definition, instead of simplifying using this definition, okay, so we can directly use this exponential formula in order to simplify the both trigonometric function, that is cos and sin functions. Okay, here we will get directly both the Laplace transform of cos at value and also the Laplace transform of sin at value. Okay, right. So next, similarly, you can apply the same method for the Laplace transform of sin ht. Sin ht, it is for hyperbolic function. So for hyperbolic function, you will get it as a by a square minus a square. So without hyperbolic, we can write, we will get it as a by a square plus a square. If you have the hyperbolic, then in the denominator you will get the minus value. That is a by a square minus a square. Okay. So sin h x, we know the formula in terms of exponential for the hyperbolic function of sin is nothing but sin hx is given as e power x minus e power minus x by 2. Okay, right. So applying this formula in this equation, that is Laplace transform of sin ht is equal to Laplace transform of e power at minus e power minus at by 2. So convert this hyperbolic function into the exponential form. Okay, right. So in place of x, will have the 80. So wherever we will have the x, you can simply substitute as a 80 only. Okay. Right. So now, so by linearity property again it can be divided. The sum of or the addition and subtraction of the two functions can be divided into the individual function. Laplace transform of the individual function. Okay. Right. So Laplace transform sin ht is equal to, so this denominator 2 is a constant, then it can be taken as 1 by 2 into Laplace transform e power at as one term minus Laplace transform e power minus at as another term by using the linearity property. So what is Laplace transform e power at? Already we have evaluated this function. Okay, Laplace transform e power at is nothing but 1 by s minus a. Okay, minus. What is Laplace transform e power minus 18? It is nothing but 1 by s plus a. So if you take the LCM of these two, okay, then if you simplify, then what you will get finally, you will get it as a by s square minus a square. And this function is defined for s plus s minus a greater than 0, and this function is also defined for s plus a greater than 0. Okay. Right. So if you take the LCM of these two, then what you will get? S plus a. This term is multiplied with the first term of the numerator, and this term is multiplied with the second term of the numerator. So s plus a minus of s plus a by s minus a into s plus a. So this minus s and plus s both will get cancelled. Okay, after simplification, then both will get cancelled. Then in the numerator you will get the 2a, by in the denominator it is a minus b into a plus b. Then you will get a square minus b square into multiplying by 1 by 2. 1 by 2. These two will get cancelled. Finally, you will get a by s square minus a square. So this is the Laplace transform of the hyperbolic function. That is nothing but sine function, sine h. It can be directly written as a by s square minus a square. Similarly, for the cos function, Laplace transform of cos h is given as a by s square minus a square. Sorry, s by not a by. Sorry, it is s by s square minus a square. A small mistake here. Okay, Laplace transform of cos h can be written as s by s square minus a square. Okay, all right. So now we have to find out. So far we have studied. So how we are going to apply the Laplace transform for the basic functions, all the basic functions. So far we have studied. There is nothing but we have studied for Laplace transform of e power at. Either it can be plus or minus. Okay, we have studied for Laplace transform of 1. And we have studied for Laplace transform of t power n type of method. We have studied the Laplace transform of sin 80. Now we are going to evaluate this Laplace of sin 80, and we got the directly by yes, the Laplace transform sin 80 value or cos 80 value or e power 80 value or Laplace transform 1 value in terms of S domains. Okay, are converting from time domain to S domain, and we already evaluated all these functions. Okay, now we can do the problems by using the basic functions which we have evaluated so far. Okay, all right. So now find the first problem. Find the Laplace transform of t cube minus 3t square plus 2. Okay, so here we'll have the addition and subtraction of the functions. It is nothing but multiple functions. We have 2 or more functions here. So either it can be added or subtracted one function with respect to another. So again, we are going to apply the linearity property. So when you are applying the Laplace transform of this type of function, then you have to use the linearity property. So according to linearity property, you have to apply individually Laplace transform for the first function, Laplace transform for the second function, Laplace transform for the third function. Okay. So what is Laplace transform of t cube? So generally you have to apply the basic formula, Laplace transform of t power n. What is Laplace transform of t power n? N factorial by s power n plus 1. N factorial by s power n plus 1. In place of n, what we have here? 3. So that is nothing but 3 factorial by s power 3 plus 1. Okay. So Laplace transform of t power 3 is nothing but 3 factorial by s power 3 plus 1 by using this basic formula. Minus. Here 3 is a constant, it should be taken outside 3 into. Again, Laplace transform 2 square is nothing but 2 factorial by s power 2 plus 1. So in place of n, we'll have the 2. So 2 factorial by s power 2 plus 1, which is represented here. Next, Laplace transform of 2. Okay. So Laplace transform 2 is nothing but, or to take that 2 outside. So then 2 into Laplace transform of 1. Okay. 2 into Laplace transform of 1. So 2 into what is Laplace transform of 1? That is nothing but 1 by s. Already we did in the previous classes, or we have evaluated all this function basic formulas. Okay. Right. 3 factorial is nothing but 6. The 3 factorial can be represented as 3 into 2 into 1. 3 into 2 into 1. That is nothing but 3 into the 6. 6 into 1 is nothing but 6. If you have the 4 factorial, 4 factorial is nothing but 4 into 1. So 4 3 are 12, 12 2 are 24, 24 into 1. So this is 4 factorial. Similarly, for 5 factorial, you get the 1 2. Okay, you have to remember this factorial values. Then you can directly put these values, factorial values directly, factorial of any number directly. Okay. So 3 factorial is nothing but your 6. Okay, 6 by s power 4 minus 2 factorial is nothing but 2. 3 into 2 is nothing but 6. 6 by s power 3 plus 2 into 1 by s is nothing but 2 by s. So this is the way you have to simplify the Laplace transform of the basic function which we have given here. Okay, basic functions which we have given in a given problem by using the linearity problem. Now we'll go for the one more problem on this. Okay, so find the Laplace transform of e power 2t minus 4t cube plus 3t. Again, you have to apply the linearity property for this function. So Laplace transform of e power 2t. Okay, so Laplace transform of combined of 2 or more functions. Is the sum of 2 or more functions. Sum addition or subtraction of 2 or more functions. Then it can be evaluated as the sum of the Laplace transforms of the individual functions or the separate functions. Okay, right. So I am writing the Laplace transform to this function as separate. Laplace transform equal to t minus Laplace transform 4 into t cube plus Laplace transform of cos 3t. Okay, right. So what is Laplace transform of e power 2t? It is of the form of Laplace transform of e power 8. So already we did this one, so that you will get as 1 by s minus a. What is a value here? In place of a, we'll have the value as 2, that is nothing but 1 by s minus 2, which is represented here. Minus 4 is a constant which is taken outside. 4 into what is Laplace transform of t cube? T cube is nothing but 3 factorial by s power 3 plus 1. It is Laplace transform t power n form plus. What is Laplace transform of cos 3t? That is nothing but it is of the form cos 8t. Laplace transform of cos 8t. That is equal to 1 by s by s square plus a square. S by s square plus a square. In place of here, we'll have the value as 3. So you can write it as s by s square plus 3 square. Okay. So just you have to remember the basic theorems which we have evaluated in the previous classes. You have to note down on a paper in order to evaluate or simplify these functions. Okay. So 1 by s minus 2 minus 3 factorial is nothing but, what is the 3 factorial value? 6. 6 into 4 is nothing but 6 into 4. 6 say 6 4 are 24, not 12 here. 6 4 are 24. Okay. Right. So 1 by s minus 2 minus 24 by s power 4 plus s by s square plus 3 square value is nothing but 9. So this is the way you have to simplify the Laplace transform for the sum of 2 or more functions has been given. Okay, so for this type of functions you have to apply the linearity problem. So this is the another problem. Okay, find the Laplace transform of this function. So we have to apply by linearity property Laplace transform of the first function, and Laplace transform of the second function, and the Laplace transform of the third function. Okay. So whatever the constant which is multiplied by to that function, that can be taken outside. The Laplace transform of the first function plus pi into Laplace transform of the second function plus pi into Laplace transform of the third function. Okay. So Laplace transform e power minus 80 formula. So Laplace transform e power minus 80 is nothing but 1 by s plus a. In place of a, we'll have the 2. So 1 by s plus 2 plus 5. What is Laplace transform of cos 80? Cos 80 is nothing but s by s square plus a square. A value is here 2. S by s square plus 2 square. That is nothing but 4 plus 5 into. It is for sin 80. So 3a by s square plus a square. A value is here 3. So 3 by s square plus 3 square. That is nothing but. So finally, after simplification of this, we get 9 by s plus 2. So here 5 into s is nothing but 5s by s square plus 4 plus 5 into 3 by s square plus 9. So this is the way you have to simplify the problems on the linearity property. Okay. All right. Now we'll go further another part. Okay. This is very important model. So now find the Laplace transform of sin square 3t. Okay. So we have the formula for Laplace transform of sin 80, okay, or cos 80. So we don't have for the square term. So we don't have the square term, okay, for sin or cos function. So for this we have to convert by using the trigonometric functions, by using the trigonometric ratios, so that you will get in the first semester regarding this. If you don't remember the formula, just I have explained you. I have represented the formula here. How you are going to evaluate the sine or cos function if you have the square term. Okay, if you have the square, that is nothing but if you have the power, the sine and cos power term, then you have to simplify by using this formula. Sine square a is equal to 1 minus cos 2a by 2, or cos square, or sine square a or 80, whatever it may be. In place of a, it is having the 80. Sine square 80 is equal to 1 minus cos 2a by 2. So here, this is the form which is represented here. Sine square 80. What is a here? 3. In place of a, we'll have the 3. So apply this formula to this function. Apply this formula to this function. Okay. Right. So if you apply this formula to this function, what will get? 1 minus cos 2 into, what is a value? 3. 2 into 3 is nothing but 6. 1 minus cos 60 by 2. So that is represented here. Okay. Again, by using the linearity property, so you can apply the Laplace transform of 1 separately and the Laplace transform of cos 60 separately, and take this denominator 2 as roots. 1 by 2 into Laplace transform of 1 minus Laplace transform of cos 60. What is Laplace transform of 1? 1 by s. What is Laplace transform of cos 60? It is of the form Laplace transform of cos 80. That is nothing but s by s square plus a square. A value is 6. S by s square plus 6 square. 1 by s minus s by s square plus 36. Square is nothing but 1. So if you want, you can take the LCM and you can simplify. Otherwise, you can put it up to here only. Okay, you can evaluate up to here only. Okay. So I have done this problem with the further simplification. Okay. So take the LCM of these two. What is LCM? S, and another part is nothing but s into s square plus 36. So this s square plus 36 is multiplied to the numerator of first term, and this s term is multiplied to the numerator of the second. So what is it? S square plus 36 into 1 is nothing but s square plus 36 minus s into s is nothing but s square. So plus s square and minus s square both will get cancelled. Finally, we get the 36. 36 by the denominator is rather s into s square plus 36. Okay, and this 2 1 280. This will get cancelled. 2 1 2 8. So finally, we will get 18 by. So this is not 36. This is your 18. So 18 by s into s square plus 36 is the final answer. So if you want, you can put it up to here only, or if you want to further do the simplification, then you can expand up to the last simplified part. Okay. So it is not 36, it is 18. Okay. Right. So next we will go for one more important problem. That is Laplace transform sin omega t plus theta. The Laplace transform sin omega t plus theta. Okay. So here it is having a combination of omega t plus theta. First we have to evaluate this entire function. So this entire function is of the form of sin a plus b. So this is your a and this is your b. So this can be simplified as by using the formula sin a plus b. That is sin a cos b plus cos a sin b. Here a value is equal to omega t. The b value is equal to theta. This is your a value and this is your b. Okay. So wherever you will have the a, you have to substitute omega t. Wherever you will have the b, you have to substitute the theta. After substituting in this equation, Laplace transform of okay. So Laplace of sin omega t plus theta is equal to so Laplace transform of sin a value is omega t into cos theta, that is b value is theta. So Laplace transform of sin omega t cos theta plus Laplace transform of cos omega t sin theta. Okay, right. So you can directly apply the linearity property to this problem. Okay, right. So here always the Laplace transform can be represented in terms of the time domain. Here cos t is a constant. We don't have the time function. It is not a time function. Okay. So that's why this cos t is a constant in the first term and sin t is a constant in the second term. Okay. That's why those two terms can be taken outside. Okay. Cos t will be taken outside. And Laplace transform sin omega t plus in the second term sin theta will be taken outside. Then you have to apply the Laplace transform cos omega t. Okay. Right. So what is Laplace transform sin omega t? It is of the form of Laplace transform sin a t. In place of a, we'll have the omega. That is omega by s square plus omega square plus sin theta into. It is also cos a t formula. So in place of a, we'll have the omega. So Laplace transform cos a t is nothing but s by s square plus a square. A value is omega here. Okay, we get omega square. So finally, here in this term, what we get? Omega into cos theta by for the first term s square plus omega square. For the second term, okay, s into s theta by s into s theta by we get s square plus omega square. If you take the LCM will be the same, and what you will get finally is nothing but LCM will be s square plus omega square, and we will get in the numerator omega cos theta plus s sin theta. Okay, this is very important problem. Okay, because most of the students will do directly this problem without applying this formula. Okay, first we have to apply this formula, then we have to simplify by applying the Laplace transform. Sometimes this problem may be given in terms of cos omega t plus alpha. You may give the problem like this: Laplace transform of cos omega t plus alpha. Be careful, either it can be alpha or it can be beta, both are constant because both are not depending on the time. So here omega t is only the depending on the time. Only this function will be kept inside, and the remaining all functions can be taken as a constant and it can be taken outside. Okay. And next very important problem is Laplace transform of sin 2t into sin 3t. Okay. So here we'll have the two functions. Both are sine functions only. So it is in multiplication. Okay, we cannot apply the linearity property to this type of function. So first what we have to do? So we have to apply the formula for this function. What is the formula for this function? That is nothing but 2 sin a. So it is of the form of 2 sin a sin b formula. We are going to apply the formula for 2 sin a sin b formula. But in this case, we don't have the 2 here. So what we have to do? So we have to multiply and divide by 2. Okay, in order to convert into this formula. You have to multiply and divide by 2 to this function in order to convert into this formula. So 2 sin a sin b formula can be given as cos a minus b minus cos a plus b. Okay, what is a here? A value will be the 2t or 3t, whatever it may be. Okay, a value will be the 2t or 3t, whatever. So 2t and a value will be the 2t and b value will be the 3t. A value will be the 2t or b value will be the 3t. Okay, right. So substitute in place of a 2t, substitute in place of b 3t. Then after simplification, what we will get? So Laplace transform of cos 2t minus 3t minus cos 2t plus 3t by using this formula. Okay, right. So I've done that, multiply and divided by 2. After multiply and divided by 2, 1 2 will be kept inside and 1 by 2 will be kept outside. So apply the formula for this internal function. Okay. So you get this one. Cos of 2t minus 3t is nothing but minus t. Okay. So 2t minus 3t is nothing but minus t. So here cos of minus t minus cos of 2t plus 3t is nothing but cos pi t. Cos of minus theta. So cos of minus theta is nothing but cos theta only. So cos of minus t is nothing but cos t only. Cos of pi t is nothing but pi t. Okay. So now we have to apply the Laplace transform of cos at and Laplace transform of cos at for these functions by applying the formula. Okay. What is Laplace transform of cos t? S by s square plus 1 square. A value is 1 here. Here a value is 5 here. So that's why s by s square plus 5 square. Okay. So this one will be simplified as this, and this one is simplified as this, and to this entire function you have a 1 by 2. Okay. So if you want, you can take the LCM and you can simplify this function, and finally you will get this. You will get this term. So you don't take the LCM here. So instead of taking, sorry, you can take the LCM here. So after taking the LCM, then finally you will get it as a 12s by s square plus 1 into s square plus 25. Okay. So simplify this one by taking the LCM, and finally we get this function. Okay. So this is the way you have to simplify for the two functions when they are in multiplication. Okay, when they are in multiplication. So mostly we'll have the sin A cos B type or cos A cos B type of functions, or cos A sin B, or sin A sin, or sin A sin B. So for all these functions we don't have the 2, okay, which is multiplied to this function. That's why what we have to do, so we have to multiply and divide it by 2 for all the functions in order to convert into the basic formula. Okay, in order to convert into the basic formula, such that then only we can apply that linearity property to these functions in order to simplify by using the Laplace transform. Okay, right. So next most important problem here. So we did this problem for the trigonometric function, Laplace transform of sin squared t. Trigonometric Laplace transform of sin squared t or Laplace transform of cos squared t, whatever it may be. Okay. So sin square at, general formula. You can consider as a general sin square at and cos square at. We did this trigonometric function, but here it is represented in terms of the hyperbolic function. Okay. So cos square, cos h square 3t. Okay, what is cos hx? Cos h2x formula, that is given as 2 cos h square x minus 1. This is the formula. So for hyperbolic function, you have to remember this formula. Okay, you have to remember this formula. So from this function, what you will get finally? Okay, to simplify this, we need the cos h square x is equal to. So if you take this minus sign to the LHS side, what you will get? 1 plus cos h 2x, right? So this 2 will be taken to the denominator to the RHS. So this is the formula. This is for cos h square x. So this is for cos h square x is equal to 1 plus cos h 2x by 2. So here we'll have the cos h square at. So here a value is 3. So simply you have to substitute a here. In place of x, we will have the ax. So here also in place of x, we will have the ax. So what is the formula for this? 1 plus cos h 2 ax by 2. This is the formula. Here a value will be the 3 here. Substitute a value 3 here. What you will get? 1 plus cos h 2 into 3, 6. Cos h 6x by 2. This is the way you have to evaluate this type of the function. That is, when you have the square, we don't have the direct formula for this. Then directly you have to convert by using this basic formulas. Then you have to simplify. Then you have to simplify by applying this basic formulas by applying the Laplace transform. So then Laplace transform of this function is simplified as 1 plus cos h 6t by 2. So then again you have to apply the linearity property. Okay. By applying the linearity property, this 1 by 2 will be taken outside. Laplace transform of 1 plus Laplace transform of cos h 6t. What is Laplace transform of 1? 1 by s. What is Laplace transform of cos h60? That is nothing but it is hyperbolic function. It can be represented as s by s square minus a square for hyperbolic. Laplace transform of cos h 80 type of functions. So it is s by s square minus a square. What is a value here? 6. S by s square minus 6 square. 6 square value is nothing but 5. So this is the way you have to simplify the functions when you have the square or cube of any function. If it is in square, then you have to use this type of equations. When you will have the cube type of the function, then how we are going to solve that problem. Okay, so this is the problem when you will have the cube type of the functions. So previously we have seen the square type of the functions. Now we have seen the cube type of the function. So when you have the cube type of the functions, what we have to do? So we have to remember the basic formula, that is nothing but cos 3 theta. If it is in terms of cos, then you have to use cos 3 theta formula. 3 theta or 3a, whatever it may. In place of theta, we'll have the a here, whatever it may be. So that's same. Only variable is changing. Either it can be sin 3 theta. Okay. If you have the sin cube theta, if you have the sin cube theta, then you have to use this formula. If you have the cos cube theta, then you have to use this formula. Okay. So here we'll have the cos 3 theta formula. Cos 3a is equal to 4 cos cube a minus 3 cos a. The 4 cos cube a minus 3 cos a. So we need this cos cube a because it is of the form of cos cube a value. Okay, it is of the form of cos cube a value. So then you have to simplify this entire function. Okay. So this RHS minus 3 cos a will be taken to LHS, then you will get it as a plus. So cos 3a plus 3 cos a. That is nothing but 4 cos cube a. 4 cos cube a. So we need to find out this cos cube a. Okay, that's why I have taken as 4 cos cube a as one side, and this minus 3 cos a will be taken to LHS, then you will get it as a plus. So we have a cos 3a and the LHS side plus 3 cos a. 3 cos a which will be taken from the RHS, which is shifted to the LHS by. So we need only cos cube a. So we have multiplied by 4 to this cos cube a, that will be taken to the denominator to this function. So cos 3a plus 3 cos a by 4. Okay. So this is the way you have to simplify the when you will have the cube type of the function. Okay. You will have the cube type of the trigonometric function. Okay. Right. So in place of a, what we have 2t. In place of a, we have the 2t. Wherever you will have the a, then you have to simply substitute as a 2t, and then you have to evaluate this function. So finally, Laplace transform cos cube 2t is given as, to apply this formula here. So cos 3 into a. In place of a, you have to substitute as 2t. Why? Because in place of a, you have the 2t. Cos 3 into 2t plus 3 cos a value is nothing but 2t by 4. Okay. Right. 3 into 2t is nothing but 60. Cos 60 plus 3 cos 2t by 4. So this 1 by 4 will be taken outside, which is a constant. 1 by 4 into. So you can apply the Laplace transform to this combined function as individual. So now 1 by 4 into what is Laplace transform cos 60? S by s square plus 36 plus 3 into 3 is a constant, 3 into what is Laplace transform cos 2t? That is nothing but s by s square plus 4. Okay. Right. Finally, s by s square plus 36 plus 3 into s is nothing but 3s. 3s by s square plus 4. So this is the way you have to simplify the Laplace transform for the cubic function. That is, so if you have the sin cube theta or Laplace transform of cos cube theta, so we have to use the cos 3a or sin 3a formulas in order to simplify and get the sin cube theta formula or cos cube theta formula. Okay, right. So this is the way you have to simplify. We'll see the applications of this Laplace transform. So basically, this Laplace transform are very much useful for simplification of algebraic functions. Okay, and it also useful for solving the linear differential equations for both the ordinary and the partial integral functions. Okay, or the equations, and also it can be used for the in the case of the partial differentiation functions, and also the integral equations, and also in the evaluation of the definite integrals. And this Laplace transform is also used to convert complex differential equations to simpler form having the polynomials. Okay. So, and next is it can also use it to convert the derivatives into multiple domain variables and then convert the polynomials back to the differential equation using the inverse Laplace transform. That all these types of definition, all these types of the application that we will discuss in the inverse Laplace transforms. Okay, in the Laplace transform and also the inverse Laplace transform. Now we are going to convert when you will apply the Laplace transform for the differential form and Laplace transform for the integration form and also the Laplace transform for the differential type of equations. Okay, and this Laplace transform are mostly used in the telecommunication field. Okay, to send the signals to the both sides of the medium. Okay, so that is we are going to convert the signals from time domain to frequency domain and again back to frequency domain to time domain. So this can be done at the transmitting side, this can be done at the receiving side. Okay, so for example, when the signals are sent through the phone, then they are first converted into the time varying form and then superimposed on the medium. Okay, so we are going to convert from one form to another form, and it is also used for many engineering applications such as in the electrical circuit analysis, the digital signal processing, and the system modeling processing. Okay, right. So this type of applications can be used. Laplace transform applications can be used in the electrical circuit analysis and the digital processing, okay, the digital signal processing. Okay, right. So these are the formulas which we have discussed so far in the first time in the present class. Okay, these are the basic formulas we have to be remembered in order to evaluate the Laplace transform and the different functions. Okay, right. So these are the some frequently asked questions. We have to be simplified for this. So already I have explained all these model problems. Okay, in the previous examples. Okay, so far we have explained all the problems that are same as whatever the problems which I have given here. Okay, and these are some assignment questions I have given for you. Then you have to evaluate. If you don't get this one, then you can ask me. Then I can explain. Okay. Right. So reference textbooks for this is nothing but so in order to find each and every mathematical applications or the formulas that you can thoroughly check by using this textbook. That is, one is the engineering mathematics, the BV Ramana. Okay, and next is the higher engineering mathematics, the ESB. These are the two standard textbooks which you can refer this Laplace transform. All the different types of functions, how they are evaluated in theoretical and also in the practical analysis.